Hello everyone, my name is Rayyan. I'm from the group Comting, and today I will describe my code. So my part is like part 1 and part 2. So first of all, the part 1. Part 1 is input total number of students. First of all, in the first part of the program, the system begins by asking the user to enter the total number of students in the classroom. The input is stored in a variable n, which is represent how many students recorded will be processed. This value controls how many times the program will repeat the data collection process in the next step. An empty list called students and then created. This list is used to store all student information. Enter the user. Each student data will later be added. This list is a structured format. This step ensures that the program knows two things. First of all, how many students exist and when they store their data for further processing. And the second one is part 2, collecting the student data. So in this collecting student data, first of all is the student identification. The program displays the current student number, for example, student 1 per 10. This helps the user keep track of which student is being entered. And then number 2 is name input. The user input the name of the students and extra space are removed to keep the data clean and consistent. First of all, the part 3 is the performance. Wait. The performance level input. So the user enter the student performance level using the one of three categories: high, medium, or low. And then the fourth one is accessibility requirement. It's a true and false situation. The user specifies whether the student needs accessibility settings or not. And then the number 5 is conflict information. The user enter the name of another student with whom there is a conflict or dash if there is no conflict. If dash is entered, the program stores the conflict value as a none, indicating no setting restriction. The number 6 and the final one is data storage. Data storage, all collected information for the student is stored as a directory containing name, performance level, accessibility requirement, and conflict information. That's it for my part. Thank you.
Hi, my name is Alifa Thahira. So next point is the accessibility. In this code, the program asks the user whether the student needs accessibility um, or not, and then the answer is converted into a Boolean value. If the input is yes, then the variable access becomes true, but if it's not, then it becomes false. And then next point is the conflict. um, the program asks if the student has a conflict with another student or not. But if there is no conflict, so the value is set to none. But if there's a conflict, the input is stored as the conflict name. Finally, all the collected data is stored in a dictionary. The dictionary contains name of the student, performance, access, and conflict of the conflict with other students. And then this dictionary is appended to the student list. Thank you.
Hello, my name is Tabina Zulfikar, and the next step is sorting and setting logic. So, in this section of the code is responsible for arranging the setting order in a logical and a fair way. And instead of random placement, the algorithm in here applies a few clear priorities so the setting becomes more organized and intentional. And first, the code separates students based on accessibility needs. And as you can see here, there was two categorized. The first one is accessible, and the other one is other students. And in here, the students who need accessibility are stored in a separate list, and the students is always placed at the front of the classroom because their physical or learning needs should be prioritized before other consideration. And after that, the code focuses on students who do not need accessibility, and these students are sorted based on their performance level, like high, medium, and low. And a ranking dictionary in here is also used to convert performance categorized into a number, and this make it easier for the program to sort student from high to low performance. And this goal here is not to label student but to create a balanced seating order where higher performing student can help maintain engagement near the front. And next is the code that handles social conflict between students. So if there was a student who has a conflict to uh, another student, the student is moved into a separate list, and the student and these students are later placed at the back of the sitting order, and this is help the reduce distraction and negative interaction during class. And finally, all groups are combined to produce the final seating arrangement, like the final the final standing order follows a clear sequences, like a student with accessibility needs is going to be placed at the first, and the student without conflict is ordered by performance, and lastly, student with conflict. So yeah, that's it.
Hello everyone, my name is Nayla Safira from Group 5 and I'm continuing the presentation of my group's code. Um, so for the last, we have the display result. It will display all the seating arrangement based on the input data on the previous codes, which will display the final seating order, the seat, the name, and the performance. With some notes are student needing accessibility are seated in the front. Conflicts are separated by placing related student farther back. The performance level are arranged fairly from front to back, and the algorithm kept simple and easy for academic evaluation, which we will try to run this code. Um, okay, so there are 6 students, for example. Which these are the results. The final seating order, the seat 1 will be Ray with medium performance, Arya, Mira, Mia, Mai, and Aki. That's all from my group. Thank you for listening.